Yesterday we talked about what we do when we are given a parallelogram in the proof, and there were 6 properties of a parallelogram that you could choose from in order to get to the proof line. Sometimes you might have used one of them, sometimes 2, sometimes 3 or more. It all depends on what the proof line is asking you to prove. Today we're working in the reverse order, and our questions today are going to be telling us that we are supposed to prove that we have a parallelogram. And I want you to notice that it says that there are 5 ways to prove the parallelogram. And a lot of these are going to look familiar. For instance, in question number 1, it says if both pairs of opposite sides are congruent. Well, that should make sense because we know that yesterday, if it was a parallelogram, both pairs of opposite sides were congruent. So today it's the reverse, and they're saying if you can make them congruent, both pairs of opposite sides, then your shape will be a parallelogram. So if I was going to go in and write down what this means, it would basically be me saying if AD is congruent to BC and AB is congruent to DC, then I would know that ABCD is a parallelogram. In number 2, it talks also about another way to show that you have a parallelogram, and that is going to be to have both pairs of opposite sides be parallel to each other. So for us, if we have both pairs of opposite sides parallel, which means that those are parallel, and we also have this pair of opposite sides parallel, so AD is parallel to BC, that what ends up happening is if those 2 things occur, then we can say that ABCD is a parallelogram. Looks a lot like what we do with a parallelogram if we are given one, but this is working in the reverse order. Number 3, both pairs of opposite angles are congruent. So basically in this case, if I could find that angle A is congruent to angle C, and notice that there's an and in there, if I could show that angle B was congruent to angle D, then I could say that ABCD is a parallelogram. So notice it says both pairs of opposite angles, both pairs of opposite sides. So it's 2 things basically that you're looking for. When we get to question, or I should say property number 4, it changes a little bit. Instead of having both pairs of opposite sides, now it says one pair of opposite sides, but it has to be both parallel and congruent. You can pick either pair of opposite sides. So if we go back and we take a look at this picture here, if by chance we could get these sides to be both congruent and parallel, that would be enough to show that we had a parallelogram. So if I could get that AB, line segment AB, is parallel to line segment DC, and the same AB line segment congruent to DC, then I could say that ABCD is a parallelogram. So this one's a little different because it's one pair of opposite sides, but 2 things have to occur on it. In this case, please note that if instead of getting the top and bottom opposite sides congruent and parallel, if instead you had gotten the left and right opposite sides congruent and parallel, the same thing would have worked. And then the 5th thing here is if we can show that the diagonals bisect each other. So if you are showing that diagonals bisect each other, what that means is that you have to show that M is the midpoint of one diagonal and M is the midpoint of the other diagonal. So in here, if I can show that BD and AC bisect each other, then ABCD is a parallelogram. And in order to show that they bisect each other, what this really means is that I eventually need to show that M is the midpoint of both of them, of BD, and I'd have to show that M is the midpoint of AC. So there's two things that I have to show in there if I choose to use that reason. Of all of the ways to prove that we have a parallelogram, there are three that you're going to use most often. Doesn't mean that you're going to use them all the time, but the ones that I see occurring most often is going to be number 1, number 2, and number 4. So those are the three that you're going to be most likely to use. So if we take a look at our first proof here, we're asked to prove that PS and QR are congruent to each other. Now, the interesting thing about that is I'm putting little dots on them because that's where I'm supposed to end up, but they're not inside of a triangle. So this isn't really going to be a CP-CTC, but there is going to be a relationship that we have to come up with before we can prove those two sides congruent. So if I take a look at the given information, the first given says that these sides are parallel. The second given says that these sides are also congruent to each other. I need to take those two pieces of information and say, if I know that those things are true, then what I know is that in my shape, PQRS, notice how I named that. I know that it's a parallelogram, and I named it PQRS because I started in the upper left at P and I worked my way around the shape clockwise. And my reason for this is if one pair of opposite sides is both parallel and congruent, the quadrilateral is a parallelogram. And then, once I know that it's a parallelogram, so I have this right here, I have this parallelogram. We'll put a little bow on it over here. Remember, that's our little gift. And one of the things that I know is that if I have a parallelogram, these opposite sides have to be congruent to each other. So my final step of the proof is going to be to say, oh, we just made it a parallelogram? Okay, well that means then all the properties of the parallelogram hold true, which is that opposite sides of a parallelogram, which we just determined it was, are congruent. Super easy proof. You'll probably never see one that's this easy, but it's a nice one to start with to get you used to working with the vocabulary and the reasons. Okay, the next question is also an easy one, and in this one, it's telling us that angle P and angle R are congruent, and then it's telling us that angle Q and angle S are congruent. And as soon as I take a look at those two things, what I notice is that my PQRS is now going to be a parallelogram, because one of the ways to make a parallelogram is if both pairs of opposite angles are congruent, the quadrilateral is a parallelogram. So that's just flat out one of the rules. They gave me everything I needed to turn that four-sided shape into a parallelogram. And then I get to the point where I say, oh look, this is a gift. Now I know that I have a parallelogram, and one of the properties of that parallelogram is that I get opposite sides parallel to each other. So once I know it's a parallelogram, opposite sides are parallel, and the sides that they asked me to prove parallel, PQ and RS, are sides of it. So my shape that's a parallelogram has opposite sides parallel. So opposite sides of a parallelogram are parallel. All right, and then I'm going to go ahead and move on to question 3. just a note, question 2 is a super easy question. The odds of you having many that are that easy are next to nothing, but we're trying to make sure that you get used to working with the vocabulary and the reasons. In question 3, we're asked to prove that we have a parallelogram. And then I see some givens here, and we're going to go ahead and take a look at those givens and see if we can figure out what's going on. When I look at this first given here, which is that these two angles are congruent to each other, one of the things that jumps out to me immediately, and this may or may not be what you see right away, is that BCADE, that's these two angles here and here. And those two angles are sitting in the pockets of the F, which means that if the corresponding angles are congruent, lines are parallel. So in this case, I can put in here that line segment AB is parallel to line segment DC. That might not look like a big to-do, except that now in the shape that they're asking me to prove a parallelogram, which is this one that's here, I have one pair of opposite sides parallel. So I'm partway to using one of my 5 ways to make a parallelogram. I'm going to move on here and take a look at the other information that they give me. And if I look at the other information that they give me, one of the things that I notice is that angle 2 and angle 3 are congruent. You may say, why would they give me those two angles? What I notice is those two angles are sitting in one triangle. And if two angles are congruent, the opposite sides are congruent. So I'm going to get that line segment CD is congruent to line segment CE. My reason, that same reason we've been using for quite a while now, if two angles of one triangle are congruent, the opposite sides are congruent. I don't know right this minute what I'm doing with that, but I do know that when I look at that it makes sense. So I'm going to go back now and say, okay, I've done what I was supposed to do with angles 2 and 3. I'm going to go ahead now and look at the next given. And when I look at the next given, it tells me that I have this side AB congruent to this side CE. I'm just realizing I never colored that last one, that these two sides are congruent. And what I notice is that both lines have a link between them with line segment CE. So here's what I notice. I notice that there's a CE here and there's a CE here, so that becomes the links between the two lines, which means that essentially line segment AB will be congruent to line segment CD. So when I have two sets of congruents and one link between them, that is the reason that we know is transitive. And what I also know now is that once I have that, I have these sides also congruent. So if I was to just draw this shape, what I have in this shape is that these sides are congruent, and then I also have that these are parallel. And if one pair of opposite sides is both parallel and congruent, then the shape will be a parallelogram. So I'm going to put that in here. ABCD is a parallelogram because if one pair of opposite sides is both parallel and congruent, the quad is a parallelogram. So I know that when we go through and do these, I make it look a little bit easier than maybe what you can do it on your own, because I have those properties memorized of a parallelogram, and I know what the 5 ways are to turn my shape into a parallelogram. So when you work on your homework with this, you're going to want to make sure you have your notes out, unless you've been able to memorize them quickly. Eventually you'll want to have them memorized, but right now while you're still practicing, it would be helpful to have your notes out while you're working on your homework.